Hello everyone, for today's topic you're going to learn about the relative atomic mass. Can everybody say relative atomic mass? Relative atomic mass. Okay, before we proceed with our discussion today, let's have a short review first with our previous topic. So, who can remember our last lesson? It is all about the historical development of an atom. So, we learned who discovered atom, just like one of the uh, philosophers or scientists who discovered atom is John Dalton. Okay, so he said an atom is from the word atomos, meaning very small, and it is indivisible. You cannot divide it. Also, who discovered the different subatomic particles. So we discussed who discovered proton, neutron, and electron. Okay, so as what I have said, today we're going to focus our lesson on the relative atomic mass. Okay, so it is a great advantage if you have your periodic table with you right now. Okay, so let's have the vocabulary words. Please repeat after me. Relative. Can everybody say relative? Let's spell relative. It is letter R, letter E, L, A, T, I, V, E. Relative. The next word is atomic. Can everybody say atomic? Okay. Let's spell atomic. Atomic spell is letter A, T, O, M, I, C. Atomic. Another word is mass. Can everybody say mass? Let's spell mass. M, A, S, S. Mass. Okay, so earlier development of relative atomic mass. So atomic or an atom is very tiny. Okay, very small. Therefore, it is impossible to determine its mass by weighing. Okay, you cannot say, oh, an atom is having 1 kilo. No, because it's very small and it's impossible to weigh it. Okay, so you will know the exact mass of an atom by weighing or by using any weighing scale. So how are we going to do this? Okay, so the chemists compare the mass of an atom with the standard atom. Okay, this is how they are going to know the mass of an atom, by comparing it with an atom with a standard atom. Okay, so the mass of an atom when compared to a standard atom, it is known as the relative atomic mass, or with the symbol AR. Okay, again, AR stands for relative atomic mass. Okay, and it has no unit. So what do you think is the reason why there is no unit for the relative atomic mass? Okay, so this one, why is the relative atomic mass of an element without a unit? What do you think is the reason? Okay, so this is the reason. The relative atomic mass is not the actual mass of an atom. Okay, this is not the actual mass of an atom, because no one knows the exact or the original mass of an atom. That is why it is only a comparison value. Therefore, the relative atomic mass has no unit. Okay, at first, chemists use hydrogen atom as the standard atom because it is the lightest. Because we all know what is the lightest element. is in the periodic table is the hydrogen, and this is also the first element located in the periodic table. Okay, so chemists use hydrogen atom as the standard atom. Okay, however, many elements cannot react with hydrogen. Okay, thus the relative atomic masses of these elements cannot be determined experimentally. So that is the problem for hydrogen as the standard atom. Okay, so furthermore, the existence of hydrogen as a gas at room temperature makes it difficult to handle. So it's not easy to handle gases. Okay, so that's another big problem why hydrogen atom cannot be the standard atom. Okay, so again, they decided after hydrogen, so they decided oxygen atom as the standard, okay, to replace hydrogen as the standard atom. Okay, so what happened? So, however, problem arose when existence of three isotopes of oxygen were discovered. Okay, so another problem occurred. That's why oxygen cannot be the standard atom because of these three isotopes of oxygen. So, can you still remember what this isotope is? Having the same number of protons but different number of neutrons. Okay, another. So, they have this confusion occur. So chemists use natural oxygen containing all the three isotopes as the standard, whereas physicists use isotope oxygen-16 as the standard. So there's a confusion between the chemist and the physicist. So that's why they decided oxygen cannot be the standard atom. Finally, in the year 1961, a new single standard, carbon-12, was agreed upon internationally. So agreed upon internationally meaning it is all over the world. So they agreed all over the world that the mass of one carbon-12 atom was assigned as exactly 12 units. Okay. So the relative atomic mass, or AR, based on carbon-12. So this is the standard atom. Okay, carbon-12 was chosen for a few reasons. So these are the reasons why carbon-12 was chosen for a standard atom. Okay, letter A. Carbon-12 was already being used as the reference standard in mass spectrometers. Letter B. Many elements can combine with carbon-12. Letter C. Carbon-12 exists as a solid at room temperature and thus can be handled easily compared to oxygen because hydrogen is a gas in the room temperature, where carbon-12 is solid at room temperature, so it can handle easily. And the last reason is carbon-12 is the most abundant carbon isotope, occurring about 98.89%. So it's a lot. Thus, the mass of exactly 12 units assigned to one carbon-12 atom as the accurate value. So based on the carbon-12 scale, the relative atomic mass, or AR symbol, of an element is defined as the average mass of one atom of the element when compared with 1/12 of the mass of a carbon-12 atom. Okay, so this is the formula. The relative atomic mass of an element is equals to the average mass of one atom of the element over, so one average mass of one atom of an element over 1/12 times the mass of one carbon-12 atom. Okay, so this one is the relative atomic mass of an element. For example, the average mass of one sodium atom is 23 times more than the mass of 1/12 of carbon atom. So what is the relative atomic mass of sodium? So how are we going to do this? So as you can see, if you have your periodic table, the average mass of sodium is 23. Okay, so let me read the question first. The average mass of one sodium atom is 23 times more than the mass of 1/12 or 1/12 of carbon 12 atom. What is the relative atomic mass of sodium? Okay, so using this formula of the relative atomic mass of an element is equals to the average mass of one atom of the element, which is 12. This is the average mass of one atom element, so I write 12 here. Then equal over this white line and this light blue line here, it means over 1/12 of carbon atom. Okay, 1/12 times 1/12 times the mass of one carbon 12 atom. So I will write here 1/12 times times the mass of one carbon atom is 12 times 12. So this is the average mass of one atom of an element. What element? The element is sodium. Sodium is having this 23 average mass. So I write here 23 over 1/2 times 12. The answer is 23. So the average mass of titanium is 48 times greater than the mass of 1/12 of carbon atom. Question: what is the relative atomic mass of titanium? So let me read the question again. The average mass of a titanium is 48 times greater than the mass of 1/12 of carbon 12 atom. What is the relative atomic mass of a titanium? So I would like you to use the same formula as the same with our previous slide. So what is the average mass of an atom element here? Our element is titanium, so the average mass is 48. So we write 48 here equals over 1/12 times 12. So what is the relative atomic mass of titanium? So kindly write your answer in the comment section because that will serve as your attendance. If you're going to write only your name, then it's not your attendance. I would like you to write your name and the answer of this question. What is the relative atomic mass of titanium? So there's no need to write the unit because it has no unit.